Hey everyone, we're going to take our second day of class notes on 11.2, where today we are going to be solving exponential equations. Yesterday we were graphing exponential functions, now we're going to solve the equations. What's an exponential equation? Very similar to a function. It's an equation that has a variable in the exponent location. And one of the new properties that we need to learn when solving exponentials, one way to solve an exponential equation is to rewrite each side of your equation with the same base. If you can write it with the same base, then you can set the exponents equal. That's what that's saying. This is just a reminder that your base has to be, right? Your base is RA, the base is A. It has to be bigger than 0 and it can't be equal to 1. So we are going to look at the steps on the next slide, and then we're going to start our 4 examples, and then we'll be done for today. So the steps say, for solving exponential, one way to solve an exponential is to try to write each side with the same base, which is what I just said. Simplify any exponents if you can. That means reduce fractions, reduce numbers, distribute, and then set your exponents equal and solve. So you lose the base piece and you can just set those exponents equal and solve it as that equation. Probably a good idea to check just to make sure. As you see the first one on the screen, I'm going to slide to the paper where you'll see that again. I also have out, I guess I should have come here first, my power sheet on the back side, and this one's really old and ripped, so just bear with me. On the back side of your power sheet, you should have your base sheet. And so when I look at this problem and I'm trying to write 9 and 27 with the same base, I'm always going to look at the smaller number base first. So base 9 has 9 and then 81. So there's no way to write 27 with base 9. So then I have to observe all the other bases and see where I can see a 9 and a 27. Oh, here we go. Base 3, I see a 9 and a 27. So I can write 9 as 3 squared, and I can write 27 as 3 cubed. Then the bases would be the same, not the exponents, but the bases would be the same. So I'm going to go ahead and get this to focus, and I'm going to write 3 squared to the x. So I'm just rewriting this as 3 squared, and so the 2 with the x will become 2x. And then 27 I'm going to rewrite as 3 cubed. This still represents 27. This still represents 9 to the x power. But the property says if you can write both sides of the equation with the same base, you can take your exponents and set them equal and solve your equation. So this has a solution of 3 halves. And then you can always double check that. 9 to the 3 halves, after what we just learned in our rational exponents, you should know that means square root of 9, which is 3, and then 3 cubed, which is 27. That does work. All right, so next example, I have base 4 and base 16. So I'm going to check my base 4. And base 4, I see a 4 and a 16. Now, if you continue to look, you'll also see 4 and 16 with base 2. So either way, you can either write these both with base 2 or base 4. You'll get the same answer, just less simplifying if you use base 4. So I'm going to keep this side the way it is, because that's already in base 4. But I'm going to switch and write this as 4 squared. So keeping 4 to the 3x minus 1. But writing this as 4 squared, and then I have that quantity of x minus 2. So hopefully that's clear as to what I'm doing there. Now I wrote these with the same base, so I can use the property that says set your exponents equal and solve. I'm going to distribute as I'm setting equal, subtracting over the 2x, adding over the 1. I can see that I get x equals negative 3. So x equals negative 3. You can double check. 16 to the negative 5th power and 4 to the negative 10th power should be equivalent. All right, starting our third example. This piece looks a little funny, but after I explain, hopefully it's more clear what you'll do if you see a fraction. because we want to write them with the same base, and this has just a fraction of 1 over 216. I'm going to look at the smaller number, which is base 6 on this side. So I'm going to go to base 6. And what I observe in base 6 is that I do see 216, not 1 over 216, but I see 216. So I know I can rewrite 216 as 6 cubed. So I'm going to keep 6 to the x, and I'm going to write 1 over 6 cubed. And now I know that if this is in the bottom and I don't want a fraction here, I can bring this up and there won't be a fraction anymore. To bring anything from the top or bottom of a fraction, to switch locations, let me say it that way, you would change your sign of your exponent. So 6 to the x on the left side is going to stay. I'm going to bring this up and it's going to become 6 to the negative 3. Now the bases are the same. Now I can use the property that says set your exponents equal. There's my answer. Check 6 to the negative 3. That would be 1 over 6 cubed, which then would equal that side. Our fourth and final example for today, I see a base. This one is different than the others, but I see a 3 and a 4, so I'd probably check base 3 and base 4, see what I see there. So base 3, I see a 3 and 9. Base 4, I see a 4 and a 16. So I think what I'm going to do is keep the smaller numbers that way, and then rewrite 16 with base 4, which is 4 squared, and rewrite 9 with base 3, which is 3 squared. Because I have a 3 and a 4 here, now I have a 4 and a 3 here, so that's close. These both have exponent of 2, so you can pull it out, right? So I have the 3/4 x. Again, my goal is always to make these the same base. If I write this as 4/3 squared, I hope that you would agree that that's the same thing. 4 squared over 3 squared. Now, I don't want 4/3 as my base. I want 3/4, so that's a flip of this. And if we flip this, it changes the sign of the exponent outside. So if I want 3/4, then this has to become a negative 2. 3/4, and then I have my x. Now, do we have the same base? Yes, we do. We can set the exponents equal and say our solution is negative 2. Not mandatory to check, but I think it's pretty neat to see how this relates and how we can see what we learned in last chapter with that first one at least. All right, let me know if you have any questions. I hope that was clear. Have a great day, everyone.